Ever wondered why, despite decades of technological advances, landing on the moon is still a monumental challenge? Let's dive into the complexities of lunar landings. Landing on the moon isn't just about flying there and touching down. It's a delicate dance of physics, precision, and technology. Firstly, the moon's gravity is only about 1/6 of Earth's. This might sound like an advantage, but in reality it complicates the descent and landing of spacecraft. With less gravitational pull, adjusting the trajectory becomes a trickier task. Then there's the issue of the moon's atmosphere, or rather, the lack of it. Unlike Earth, the moon has no air to help slow down a speeding spacecraft. This means we can't use parachutes or air brakes like we do here on Earth. Every lunar landing relies entirely on rocket engines to control speed, which must be executed with precise accuracy. And don't get me started on the lunar surface itself, covered with a fine powdery dust called regolith. This isn't just any dust. Regolith is abrasive and sticky, capable of clouding up sensors, jamming mechanical gears, and even damaging the spacecraft's instruments. Moreover, landing on the moon requires managing multiple factors simultaneously: altitude, velocity, descent angle, not to mention fuel consumption and the unpredictable surface conditions. Each of these elements must be perfectly aligned. A single miscalculation can result in mission failure. Recent missions highlight these challenges. NASA's Peregrine 1 faced propulsion issues. SpaceX's Starship had its share of setbacks during tests. But there are successes too, like India's Chandrayaan-3, which marked its territory at the moon's south pole, a region potentially rich in vital resources. So why do we keep trying? Each mission, successful or not, teaches us more about our universe and brings us one step closer to becoming a multiplanetary species. And that, my fellow science enthusiasts, is why conquering these challenges is as thrilling as it is essential. This is the cutting edge of space exploration, fraught with difficulties but filled with unimaginable rewards. Stay curious, keep learning, and who knows, the next giant leap could be just around the corner. Lunar exploration has captivated humanity for decades, and its goals have evolved over time. Here are some of the primary objectives. Investigate the moon's geological history, including its formation, volcanic activity, and impact cratering. By studying lunar rocks and soil, scientists gain insights into early solar system process. The moon provides a pristine environment for studying cosmic phenomena. Observatories on the lunar surface can explore the universe without atmospheric interference. Analyzing lunar samples helps us understand the evolution of other planets and bodies in our solar system. The moon's polar regions likely contain water ice. Extracting and using this resource could support future lunar bases and serve as propellant for deeper space missions. Some propose mining helium-3 from the lunar regolith. Helium-3 fusion could be a clean and efficient energy source. Establishing a permanent lunar base would allow astronauts to live and work on the moon for extended periods. This experience informs future Mars mission. The moon serves as a testing ground for technologies, life support systems, and habitats needed for deep space explorations. Collaborating on lunar missions fosters goodwill among nations and promotes scientific cooperation. NASA's Artemis program aims to return humans to the moon by 2025, with a focus on sustainable exploration. Lunar exploration inspires students and scientists, encouraging STEM education and careers. Sharing discoveries and images from the moon engages the global public in space explorations. Private companies are interested in lunar mining, for example, rare metals, and lunar tourism. The moon could host communication satellites or serve as a relay station for interplanetary missions. In essence, the moon serves as a gateway to the cosmos, offering both profound scientific insights and practical opportunities for humanity's future. As we reach for the stars, the moon remains our closest and most intriguing stepping stone. Overcoming the challenges of lunar landings requires a combination of technological advancements, careful planning, and innovative solutions. Let's explore some strategies. Develop advanced algorithms that account for variables like altitude, velocity, and surface conditions. These algorithms can guide spacecraft during descent to ensure precise landings. Machine learning and artificial intelligence can play a crucial role in improving landing accuracy. Design more efficient propulsion systems that allow for controlled descent and landing. Innovative engines such as ion thrusters or reusable rockets could reduce fuel consumption and enhance safety. Equip spacecraft with sophisticated sensors and cameras to autonomously detect hazards and adjust their trajectory. Real-time decision-making capabilities can help spacecraft avoid obstacles during descent. Develop landing gear that can absorb impact forces and adapt to uneven surfaces. Materials science can contribute to creating lightweight yet durable landing legs. Rigorous testing and simulations are essential to validate landing systems. Simulate various scenarios, including worst-case conditions, to ensure the spacecraft's ability to handle unexpected challenges. International collaboration allows pooling resources, expertise, and lessons learned. Sharing data and experiences from successful and failed missions can accelerate progress. Leverage local resources on the Moon, such as water ice, for fuel production. ISRU reduces the need to transport all propellants from Earth, making missions more sustainable. Companies like SpaceX and Blue Origin are driving innovation in space exploration. Encouraging private investment and competition can lead to breakthroughs. Establishing a lunar base can serve as a staging point for further exploration. A base would provide logistical support, shelter, and resources for crewed missions. Set ambitious goals for lunar exploration, such as permanent settlements or mining operations. A long-term vision motivates sustained efforts and investment. As we tackle these challenges, each step brings us closer to unraveling the mysteries of the Moon and paving the way for humanity's future in space. Involving private companies in lunar exploration is crucial for accelerating progress, leveraging innovation, and sharing the financial burden. Here are some strategies to achieve this collaboration. Public-private partnerships, PPPs. Governments can collaborate with private companies through PPPs. These partnerships combine public funding and private expertise. NASA's Commercial Lunar Payload Services (CLPS) program is an example. Private companies deliver payloads to the Moon using their spacecraft. Lunar incentive prizes offer prizes for achieving specific milestones in lunar exploration. Companies compete to win these prizes, driving innovation. The Google Lunar X Prize was a notable example, though it ended without a winner. Resource mining rights grant companies rights to mine lunar resources, for example, water ice, helium-3. Clear regulations and property rights are essential. Commercial payloads and services. Companies can offer lunar payload delivery services to other organizations, for example, scientific instruments, rovers. Lunar landers can carry experiments, telescopes, or communications satellites. Tourism and entertainment companies can offer lunar tourism experiences, including flybys or stays on the Moon. Filming documentaries or reality shows on the Moon could attract audiences and generate revenue. Technology development private companies can develop lunar landers, habitats, and life support systems. SpaceX's Starship and Blue Origin's Blue Moon are examples of private lunar lander projects. Space agencies as customers space agencies, for example, NASA, ESA, CNSA, can contract private companies for lunar missions. Companies bid for contracts to provide services or hardware, investment and venture capital. Encourage private investment in lunar ventures. Venture capital firms can fund startups working on lunar technologies, lunar data and analytics. Companies can collect and analyze lunar data, for example, surface mapping, mineral composition. This information is valuable for scientific research and future missions.